This is Laura Duncan, and we will be talking about direct variation today. A direct variation is a special type of linear relationship that can be written in the form y equals kx, where k is the constant of variation or the slope. That slope has changed its name again. Instead of y equals mx plus b, when there is no y-intercept or b, we write the slope as a k. Direct variation relationships are proportional, so we know that the y-intercept is 0. In other words, this line goes through the origin. Now let's solve for k. To solve for k, we will isolate the variable by doing the opposite. This will cancel out to 1, so k equals y over x. This should remind you of something. It should remind you of the slope. Now, in something that's not proportional, we would find the change in y over the change in x. But if the slope is in a proportional line, we can simply divide the y by the x value and we'll find the slope. Let's do some examples. Number 5, determine if the relationship is a direct variation. If so, write the equation. So to determine if it's a direct variation, we can find the slope by having y over x. Now we're making sure that each y over x will simplify to be the same value. And if it will, and these all do, then it is a direct variation. You can also check this by using your stat key. So if you use the stat function on your calculator, then you'll find that y equals ax plus b. In this case, y equals 6x plus 0. If it has a 0 for the b, then it is a direct variation. And so after using your stat function, you can see the equation of this line is y equals 6x, and yes, it is proportional. Now let's move on to number 6. In number 6, I want you to begin by using your stat function. So pause the video and do that at this time. This is the information your calculator has given you, but what does it mean? Well, if we have a y-intercept that is not equal to 0, it is not a proportional relationship. That means it does not have direct variation. Now let's move our attention to application problems. The number of hamburgers that can be made varies directly with the weight of ground beef that is used. 5 hamburgers can be produced for every 2 pounds of ground beef. Write a direct variation equation for the number of hamburgers y that can be made from x pounds of ground beef. Then graph the relationship. Before we dig into this equation, I'd like to look at a dependency statement. It says the numbers of hamburgers varies directly with the weight of ground beef. That means that the ground beef is our x value, which they tell us later on in the statement. But what I want you to understand is that the number of hamburgers is our y, and our y will always vary directly with the x. The y also depends on the x. So I want you to be able to notice that the number of burgers depends on the amount of beef that you have. Now let's continue. What's the slope in this problem? Well, remember the slope can be found in a direct variation problem by dividing the y by the x. There were 5 hamburgers for every 2 pounds of beef, so that's the slope. Since this is a direct variation problem, what would the b be? Well, it goes through the origin, so you can either put 0 or 0, 0. The x-intercept is also 0. Now let's look at the equation. To find the equation in a direct variation problem, we would have y equals kx. Well, we saw that the slope was 5/2. So our equation would be y equals 5/2 x. Now let's turn our attention to the graph. First, I want you to note which one is the x value and which one is the y value. That's where that dependency clause comes in so handy. We know that the burgers is the y value and the beef is the x value. So please start with the title and be labeling your axis. When you're doing a graph for math, I also want you to use the principles that you learned in science. The science word is tails that you learned, that you need to think about a title, the axis, the intervals, the labels. And so let's look at the intervals now. What are we going to use for intervals? Should we use 5s for the y, 2 for the x values, or should we just count by ones? Make a choice and pause the video here. I chose to increase by ones on my intervals. So let's take a look at our first point. Since this has direct variation, it's a proportional relationship, we know that our line will go through 0, 0. Then for every 2 pounds of beef, 5 burgers can be made. That means for 4 pounds of beef, we would be able to make 10 hamburgers. Once you have your 3 points plotted, please use your straight edge and draw a line going through the whole graph. Please put an arrow at the end, and we're ready to move on to number 8. The three-toed sloth is an extremely slow animal. On the ground, it travels at a speed of about 6 feet per minute. Write a direct variation equation for the distance y a sloth will travel in x minutes. Then graph. Let's begin with the slope. We know it's a direct variation problem because that's what they tell us it is. We know we'll find the slope by finding y over x. Well, let's go back to the problem to find out what the y is and what the x is. The y is the distance and the x is the number of minutes. So the slope would be y over x. The y is the distance. The x is the minutes. And hopefully that will make it clear that the slope is 6 over 1, or 6. Now, since this is a direct variation problem, we know the b is 0 or 0, 0. That means that the x-intercept is also 0. Now let's look at the equation. We know it's direct variation, so it's y equals kx, where k is the slope. Since the slope is 6, we'll have the equation y equals 6x. Now let's go over to the graph. Please pause the video here to label the title and the axis. Now we have our distance, minutes, and I just titled it Sloth Movement. You may choose your own title. Remember that the minutes is our x value and our distance is our y value. Now, what intervals would be wise to use? If we're talking about our minutes, since it's every 1 minute that he can move 6 feet, we can do increments of 1, there. Now for the distance, it's a little more subjective. We really do want you to have at least 2 or 3 points visible on the graph. However, if we have a lot of points, that may be overkill. So I'm going to choose an increment of 2 for the distance. Please pause the video here, plot your points, and then check your answers. And that will conclude our lesson on direct variation.